Hello everyone, and welcome back to the Capstone Project. Today we're going to be going over the Capstone Project. It's in the title. Dummy. Alright, let's just hop right into it. So, here's all my work. If you need it, it's going to be flashing up on the screen. Lots of work, lots of K-maps. I had to start at the very basics, because I did not know what the heck I was doing. So I started with the most simplest. I started with just a simple lock. You press the button, doesn't care how far you are. Then I added the distance. Okay, that was easier. Then I added the automatic lock feature after 2 clock cycles. I realized I had to add another D flip-flop. Did not use any JK flip-flops. I don't like those. Personally. Let's get into the actual simulations. So the first version basically allowed you to lock it and unlock it automatically. I didn't like that because that means you can have the horn going and then the light going. Horn, light, horn, light, horn, light. That would be so noisy, especially if like a 2-year-old got a hold of the key fob. And so I made it so there's a little bit of a buffer. So the first design, as you see on the screen, it is a little bit flawed in that way. So I did a second design, which got rid of that feature. It makes it so you have to lock it, and then the horn goes off, and then it locks, and then you can unlock it. So once the horn cycle stops, then you can unlock. I'm just going to flash the video of all the states on it, all the features. Press the button, clock cycle, boom, locks, horn, boom, locked, horn off. Then, if you don't press the button, you're not far, not close. Clock don't do anything in that lock state. Clear it, set it to unlocked. Okay, now you're far and you don't press the button. Of course, it's not going to do anything. But, after 2 clock cycles, it's going to lock it. Because that's the automatic lock feature. After 2 clock cycles, it locks it. Clear it. Set. What's that function do? Transforms it into a weapon of mass destruction. So my stakeholders are me, my friend Shantanu. Shantanu sat next to me in my EEE 120 class, the class that I'm currently making a video for, that you are currently watching. He told me that maybe I should change up the design, not make it so it can flip-flop back and forth. So thank you, Shantanu, for helping me come up with my version 1 and 2. Yeah, I'm also the other stakeholder. I was the one who wanted it to turn into a weapon of mass destruction. So the second design is the best because I weighted it. So 1,000 points goes to how easy it is to build. The second design is a little bit easier. Less logic involved. The K-maps, much easier. Also, the demux. I added a demux because I was like, you know what? On my first design, I had that little state indicator. I could just make that into a demux, and then boom, the output is going to be much easier. So that kind of handled some of the output functions. So that was 1,000 points. I gave 1 point to that's it. That's all the points I gave it. They both had the same number of states. They both had basically the same logic, but again, number 2 was a lot easier, so that's why it got all the points, all the credit. That's basically it. I don't know what else I'm supposed to do. Like, no Verilog. That's awesome. Well, I hope you liked this video. Leave a comment or I don't know. Share with a friend. Alright, that concludes the capstone. Sayonara, everyone. I wish you the best of life.